Hello, everybody. My name is Shannon Lau. I'm the head of engineering here at Design Strike. Today, I'm going to be giving a talk about high-rate image search, and really what I'm talking about is searching for image descriptions. Okay, so I'm just going to give a quick intro about myself. I'm going to talk a little bit about the project in Design Strike, and then I'm really going to talk about the three elements, types of searches, so text, vector search, and hybrid search, and then really talk about where we are and things that we're still working on because we don't have it perfect and not necessarily getting all the results we want. Things that you can do and look at on your side moving forward. Okay. So again, as I'm Shannon, CTO or head of engineering here at Design Strike. My previous background, I've been in the software engineering field for 20 plus years, worked at companies like RBC. So those of you abroad, RBC is kind of Canada's largest bank. And before that, I was working at initially as a startup called Microscience that got acquired by a company called InView. So I was their head of engineering there, and I was overseeing them for about 5 years or so. Where I'm at Design Strike, our front end is Next.js, React Next.js, mostly some Python, but we do have some TypeScript stuff in the back. We do use a little bit of LangChain in a couple of areas. And then obviously predominantly our backend database is Mongo, and we do have GCS for storing our physical assets. And then just a little bit more about me. I'm married. I'm the father of a 10-year-old son, and most of the parents will get this, but I'm also an unpaid Uber driver where I take my son around to all of these different activities. Most of the weekends are basically me chauffeuring from one activity to another activity. Okay. So I'm just going to give a quick little demo about Design Strike, not to plug or anything, just to understand the context and really for people to understand what we're trying to solve here. Before I do that, there is one thing I forgot to introduce. Is to say I'll include a link to my LinkedIn profile. It has all my contact information on here as well. You feel free during the presentation if there's questions to ping me, ask questions afterwards. I know this is a kind of a virtual thing, and you're watching this after the fact. So if you see anything, you have questions about stuff, by all means, just ping me directly, and then we'll get on a call and pull this stuff out. Yeah, so again, Design Strike is a smart design platform, like a combination of Canva and ChatGPT. It creates ready to publish social media right now and for your brand and business. So let me just demo this off and talk a little bit about what exactly that means here. So those workflow of what we do, and I don't want to give everybody a full demo right now. I just want to focus in on how the image piece fits into this. But just at a high level, what we do is that we built our own kind of scraper that takes in a website URL, scrapes all the text, gets the industry, the tone, and identifies the fonts by looking at what are the fonts on your website, gets different colors, we identify the language, and then we get logos. And with this, we call this our brand DNA. So this detailed summary of information here is what allows us to build contextual layouts for your business that meet your business needs. So not only do we have an understanding of your business, the language, the industry, and the tone, we also have colors and logos that allows us to build out assets that are in line with your expected colors, brand colors, and logos. So the general workflow is this, is that you can see we built out a series of topics that we think are maybe relevant to you. So these topics are not, they're obviously, you can see here, the rise of AI, generated illustrations, and their impact on design. So these are tailored for this particular customer, right? So we use tips for effective using SVG illustrations in web development, right? So this is specifically for DrawKit, which is like an illustration asset, right? So these are all generated on the fly for the user based on their company information. So if I grab this one right now, it's a point click, you pick one button, and then boom, you're given a whole series of customized, ready to go social media posts. So I'm just going to wrap up here just quickly on this slide. I do want to just highlight a couple quick things here. So let me go here. When we talk about a social media post, it normally in our space consists of three different elements. One is the layout, so like visual placement of elements on the page and like little graphics and things like this, where should the logo be. Second thing is the text, right? So what's the copyright? We in the design space, they call this the copyright. Where's the copyright going from here, right? So this is behind the scenes using an LLM. We have a couple ones, again, Anthropic, OpenAI, and Gemini that kind of use to generate the text based on the brand and everything around that. And then there's an image, right? Right now, what we have is a stock image photography that we have access to. We also have access to a couple of sort of third parties ones where we can send search queries down to get relevant images on this. Okay, so I want to highlight one last thing. The goal of what this is, what we're trying to do, is that these images are based on our stock photography or a third-party stock photography that we have access to. We're scraping a customer's website, and ideally, especially for things like e-commerce where they have lots of product and services, it may be really useful to be able to pull those images in and load them into our product right now. So it would be a great power for people to be like, hey, we scrape your candle business and then we pull in actual physical images of your candles into these assets. I think that is really where the direction we're trying to go to. We also have access in a product is a image generator, which allows you to connect up to third parties APIs to generate right now. So it'd be also useful to be able to generate images and have those images automatically be pulled into these assets as well. So being able to have, hey, I just generated 4 or 5 images about, let's say, candles or illustrations, and have them automatically be pulled in here as give images if they're relevant about this topic. So that's a key thing that we're trying to look at here. Okay. So before I go too far in here, I'm going to talk a little bit about the tech stack that we're working with, and then we'll get into, but I want to highlight a couple of things. So just a general workflow where we are. So our front end is Vercel. I've really simplified everything down at this point. Our infrastructure is a little bit more complex than this, but I just want to highlight the main areas right now. So when we do is uploading of an image, what we do is we load the image to our GCS, and then you'll notice before we're actually saving the Mongo, we then take the description that was used to generate the image, and then we send this down to a vector embedding, and so we get a vector of that string. If you come over here, a group of kids playing hockey on a pond, so that string was sent to OpenAI and calling the vector embedding API, which then comes back with a long string, right, a long series of numbers, and then we store that with the description of the image that was used to generate it, where the image or asset are stored, the user, a bunch of other metadata, dates and times and things, and the vector embedding gets stored in one location in Mongo as part of the same collection. And then all of this is stored on JTE for our communities. Okay. I am going to highlight right now, one of the things when I was doing this presentation was that I was starting to have like blocks of code, of Python code, and it was getting a bit, I was trying to show you how to configure the ORM to run the aggregations, but I really decided just to simplify down the flow just because I felt that it was becoming the tutorial on Fast API and Mongo connections and the aggregations and a bunch of other things. And I really just wanted to narrow it down because these are virtual talks, and I think it was going to lose a lot of its focus right now. And I really just wanted to narrow in on just the implementation of the hybrid search in Mongo, again, within a Python environment. And if afterwards you have any questions about this or confusion, by all means, just like I said, you've got my contact information, ping me, and we can get on a call. So, okay. Just give me a second. I'm going to set up my demo here. Okay. Let me shift this to text. I'm using this here because it's, just so you're clear, what I did is I modified this UI here just so that for the purposes of the demo, you can see in here that I've got the text, the vector, and the hybrid. So I had to throw something together quickly, which is not in production. And that's why I'm running it here locally, is just so that I can have that control for the demo so I don't have to keep toggling and changing the back end. So I had to do some modification to the code, and that's why it's just done like this. So in this environment, just to keep things simple and confusion, I've got a couple of images here, some just different topics in them, but there are 2 in here that have similar topics. This is a picture of a black Porsche, and then you've got a picture of a red Ferrari sports car right now. So this is what I'm doing is your traditional text search on how all this works. So let me just walk through. Actually, I'll do the demo of this, and then I'm going to go I'll show through the index setup and the aggregation for this. In here, if I come over here and I type in car for a second, I'm going to see the red Ferrari. So the descriptions, I made a mistake when I was testing this out here locally. I'm not including the descriptions in that search results, but you'll notice that a picture of a red Ferrari sports car is in the description here, which is perfect as always that. But why did this car not come up? Why did the Porsche not come up? If we look at the text description, there's nothing in there about a car. Basically, the way that the text is working is looking for keyword searches, and it didn't see car anywhere in here. And so basically the results didn't come up in there. And so if I come back to this one and I go automobile, I get no results. So even though I have 2 automobiles in here, I'm getting no results back for them. And the reason is that there is no keywords. Automobile is not in this description here and is not in this description here. And so this is the root of where we're trying to solve, right? And so if we go back to my previous demo, if somebody is trying to build a social media thing about simplify your SVG usage, this may be a picture of a woman working on a computer, but how do you know, how do the association that this is linked, right? Because this description may not have anything about SVGs or illustration builders in there. It may just be a picture of a woman with a dog working at her desk doing creative work or something like that. How do you link that to? And so this type of an image would not come through in the search results on this. Okay. So let me go through just how this was set up, and then we'll keep working through and go from there. So just in my documents, in my slides that I'll be sharing with you guys, I have links to the Mongo site and some other links that really give a good example. These were the links in the documentation that I used to get up to speed on this stuff. I didn't want to just copy it over and paste it over here. And also, it's still a lot of text right now. And I just wanted to just highlight the key things. And then in my slide, you can find links to the documentation. Again, if you have questions, just ping me on LinkedIn, or you've got my email and contact information. We can find some time to review this. Okay, so the two-steps process is you need to create a search index, and then you need to create an aggregation, right? So the search index is you're setting up an index on Mongo collection. And here, I'm putting in, I want to make sure that deleted is an index, and description is auto-complete, and then I'm using user ID. These images are per user. So it's not like a large image catalog that's shared by everybody. It is, what we're trying to do is filtering for a user. So these searches have to be on users and maybe additional other filter criteria, and that's what I'm highlighting. So this is the search index, and then this is your traditional search aggregation. And in here, I'm doing the criteria of filtering by user ID. I will highlight this. I had mentioned to you at the beginning that we do have a bit of TypeScript in the backend, and that's why you're seeing a bit of a camel case, is that some of these fields were built with camel case in some of them right now. So it's just one of the things as a team that we need to address. Just give me a second here. All right, let me go on to the next one. All right, so I'm going to just talk a little bit about vector embeddings. I'm going to show a link to the page here right now in my slides here. Again, vector embeddings is on its own topic. There are a huge, enormous of YouTube videos that you can get up to speed to. There are very good, the OpenAI docs on this are very good. This is how I learned. I went through and played around with it as well. I don't want to just go and give a 5-minute speech on vector embeddings. I think if you're not up to speed on this stuff, I highly recommend just maybe watching a quick YouTube video. I'll give a quick overview of what this is, but I'm mainly providing links to how this is all going to work for you guys. Okay, so just to highlight from OpenAI, a vector embedding. A vector embedding is a vector list of floating point numbers. The distance between vectors measures their relatedness. Small distances suggest high relatedness, and large distances suggest low. So what is it really doing? Why are we using vectors? The key thing is trying to get semantic between. If you have two sentences, a red car driving up the street versus a automobile driving down a laneway, like how do you measure those similar? The keywords aren't really lining up because there's different words, but they do have very close meaning. And so this is one of the things that we're trying to solve with vector embeddings is that how do you measure semantic meaning? How do you measure the meaning of those sentences and not just looking at the keywords? And that's the core of what embeddings are trying to do, is measure the meaning and its root between those two sentences by not just looking at the keywords in those sentences. So that is at a high level. The steps for creating an vector embedding, I'll point you to this. It's very detailed. This is exactly how I'm doing it right now. But your OpenAI has them. There's a lot of other LLM providers who have a different vector embedding model that you can connect to. But basically, you send a string, your query string or your description of your image, to OpenAI. If you use an OpenAI or whatever provider, it will generate a vector embedding, and then you can save it in there. And then when you want to do a match, if you're looking for the automobile, you would send that up to OpenAI, would generate a quick embedding, and then you can do your similarity match on that. And again, I just mentioned sort of why we're doing vector embeddings is to do the similarity search or semantic search between two different strings, or in a database. Okay. So now I'm going to talk a bit about, I'm going to shift in and I'm going to go back to the demo. I think I'll be consistent here. Let me just pause here because I'm going to get my stuff ready. So in our text search, we did this, right? We did our search for automobile using text and we got nothing back, right? So now what I'm going to do is I'm going to flip this to vector and I'm going to do, so now I'm getting 2 results back. Okay, so now I'm doing a different vector embedding search, but I'm getting 2 results back right now. So when I did just a straight up text search, I got no results back because none of these descriptions in here mention anything about automobiles in their straight just text right now. However, when I put in the word automobile, I'm doing a vector embedding on the phrase automobile, and I'm trying to comparing which are the results that have the most closest match to automobile, and these are the ones that are coming up. And so this is a bit of the power of vector embeddings, is that now it can look beyond the vector search. And maybe the text search, it can be more of a meaning search. So it can understand that automobile is very similar to a sports car or is very similar to a Porsche, these have similar meanings, therefore they have higher results. We should return these results back to the user. So this is normally a point where I would pause and answer questions. But again, I'll reiterate, I'll probably keep saying this, but if you have any questions, don't hesitate to ping me afterwards and we can book some time to review this. I'm just going to talk a little bit more about the setup of the vector embedding and how it works, and then go from there. Okay. Again, this is very similar to what we've done before in the text search. Now we're doing a vector search demo. You've got the two pieces. You've got a search index and you've got an aggregation. In the search index, you're creating a vector search index. This is not everything you need to do it. Again, I have a lot of links in the notes for you on where I set this up. I'm just highlighting some of the key things that I wanted to do in my dimensions. Key things here is the number of dimensions. So how big is it? So this is 512 is a bit of a smaller dimension. You can get to things like 1024, I believe, and even bigger dimensions if you want to. Bigger dimensions come at a cost in the sense of your data storage is going to increase. So you're going to be storing lots and lots of images or lots of vector embeddings. If you're using a very large dimension for each one of them, it could slow things down and just take up a bit of the data space storage. But the bigger the dimensions tend to be, you get better results. The path, right? So I mentioned to you that we're storing the text prompt and the vector prompts, they're separate, right? So we put the vector embeddings in one column effectively in the collection, and then just the text in another column. That's why it's description values, right? So it's not the description, it's description values. They're stored separately. It's still within the same collection, same document, but separately. Then you can choose obviously the type is vector, but you can choose your similarity, and there's really three types of similarities that you can look at. So you can use cosine, dot product, and Euclidean. And again, you want to play around with those values a bit when you're doing your setup, just to see the difference. You'll see a lot of people sort of defaulting to cosine. That's not what we did as well. We've played around with a couple of them, and cosine seems to be working and getting results. And the last thing I wanted to show is just including filter past, which you can do in there. As I mentioned, we are looking for these are user-based images, not just an index of searching of everybody's images. Okay, so now we're getting into the aggregation. So how do you set up and run the aggregation? So you get your index name, the path is whatever, you pass in the embedding. So when you're doing your search, when you get automobile, we would send that up to OpenAI, get it quick. That's normally sub 1 second, maybe even faster to get an embedding on a string. And then you can limit and add some limits in number of candidates, and then you can apply your filter. And then this will basically return a set of results that will include the similarity scores for each of these as well. All right, so this is going through this demo here. So this is working well right now, but there's a challenge in it right now that when I ask for automobile, what happens if I wanted to give more weight to keywords? So like, why did the red one come up versus the black Porsche, right? So how do I control, let's say I wanted to do a black automobile to make sure I start to favor more keywords versus on the automobile, because you might be dropping some results even though the keywords are there. So how do you find that right balance? And that really is what we're talking about in hybrid search. And what hybrid search is really saying, okay, the text search is really good. It's great for the keyword matching. The vector search is really good for semantic matching, but how do I combine those two together into one? And that's really what we're talking about in hybrid search. So I'm going to come back over here and I'll go through the setup of the hybrid search, and then I'll give you a demo, and then I'm going to talk about some optimization techniques that we can do, and then share wrap it up with some next steps in terms of things that I think you can look at. Okay, so I'm just going to first start off with just the setup and that we're going to do. Again, it's really the same setup in terms of your indexes haven't changed for both your text and your search. So I've already showed that in the previous one. It's really a two-step process in terms of your aggregation. I mentioned before, I wasn't going to go through the whole setup of Mongo, just it would have been a lot more slides and a lot more information. And I just want to keep this high level and really focus on a particular, I found the focusing on the aggregation side I thought would be more valuable for you, for the people viewing this. So aggregation, part one. So the vector search. So in here, I'm including the index name, the description values. This is very similar to what we had before. So what you're doing at the first stage of your aggregation is you're running the vector search. So this is exactly what I did before, which is traditional. It's the same. You then add an additional stage after this, which is you do a union with. And so what you do in a union with is you're specifying a column. So I'm still running. This is union with would allow you to do, I think, searches across multiple collections, but I'm doing it within the same collection. I'm then creating a separate pipeline, and now I'm doing a text search. So this is within one aggregation pipeline. I can do two sets of searches. So here I'm doing a text search. Here's the index. I'm now doing compound. I'm searching the description. So now I'm doing a text search, and then I'm applying my filter criteria. So in both of these things, it's allowing me to combine those results and get them into both within one kind of query to the database. I'm running my text search, I'm vector search, and then bringing in the text search, and then I'm mixing and matching those ones together. Okay. So if I come over here now, I'm on hybrid and do black automobile. So now right now, so it's going and looking at the keywords, and I'm going to talk a bit about how you can play around with this, but now I'm getting that black automobile because I'm introducing the keyword black in that sentence, and it's getting in there right now. It's giving it more of a favorable rank and getting a better results right now. So again, I would normally stop here and just see if there's any questions. So that's the gist of it, right? So now we're talking about combining these two together to get both your text and your vector search together. So this looks great, but the question is how do I get priority order the results? Well, what can I do to make sure all I got is two sets of data, you merge them together and just dumping them out there? How do I organize and sort those results and make them more relevant? And I'm going to talk about two different things that we've done. The first one is reciprocal rank. Again, in the notes here, I'm referencing to a document on Mongo. I'm going to summarize the key attributes in there. But again, I followed their documentation pretty much to the T and was able to implement that and get it up and running for my application as well. I'm going to go through the highlighted points that I think are relevant, but I would recommend either reaching out to me afterwards, but also looking at the documentation from Mongo for this as well. Okay, so aggregation, same as before. I've got my vector in here, but you'll see that I've done something a little bit different. So now what I'm doing is I'm taking out something called the vector score, and I'm adding a reciprocal rank. So a reciprocal rank will do is you take your results, and however they're sorted, it will give them a number in starting from the first one. It gives them a ranking number where they're divided by 60 here. And this is a technique that allows you to compare different sets of results together. So here I'm applying a reciprocal rank and giving them a uniform number where they rank based on their order in the list, not their search score, but their order in the list. And that's your key thing on the reciprocal rank. So I'm applying this, give me a uniform number to work with on the vector side, and then same thing on the aggregation side. So now I have a reciprocal rank here where I can do this on the text score. Now it's looking at giving me a uniform sort of number across, again, based on how they return back in the results right now. And then lastly, you can do a final combine and merge these things and sort them by those combined settings. So it'll match them together, looking at what was the vector score search and the reciprocal rank for, say, the Porsche, what was that one, and then merge them together and then sort them in terms of their order as well at the end. Again, I refer you to the docs here on how they did it, and they give a pretty good walkthrough and a good demo that you can do. And again, don't hesitate to ping me if you have any questions on this. Perfect, great, but there's an issue there. If you go back to some of the results, the way that vector search is going to do is it will return back your results and give you a search index score in terms of how good those results were. So you will actually get this hockey scene coming back in your results. The challenge with it is that I look for black automobile. Why am I getting the hockey scene in my results? And the reason is that it's giving you a similarity search. And so in the reciprocal rank, when I was doing this, you could get some of these scores like, what's the hockey score scene back for? What's this one back for? And what you need to do is what we ended up doing was saying, I want to actually put some thresholds in these numbers to see and say, only return me back results where the similarity score is above, say, 60% or 70%. And let's say similar to the text score, you can say only show me text results where the text search score is above, say, 0.6 or whatever the number you want to play with. And so if we take that to the next stage, this is what we're looking at here, is combining now. So now what I'm doing here is I'm setting some filter criteria in the aggregation to say, before you do your reciprocal rank, I need you to filter out everything that is below this score right now. So again, I'm showing bits and pieces, not the full piece. But what I did is that I put in the minimum text score and then a minimum vector score. And so I tended the stage, which I did before this, but I was running out of space here, where I would do a match before I would actually do the reciprocal score to filter out and say, okay, anything where the minimum vector score is below, say, 0.6, you ignore. Or same thing for the text score as well. And so I can put those criteria in, And then now I know that of the results that I return with the reciprocal rank, I'm also not getting anything where that is below certain threshold values. And then that improves my score as well. Okay. One last thing I'm going to talk about, and then I'll go to the next steps. So you can also in this, when you're combining this in there, when you look at the document for reciprocal rank, they will give you an example on text weight. So you can see in here, and this is all from, a lot of this is following from the documentation. So again, I was trying to piece this in here and not have 30 or 40 different slides for you guys. I wanted to keep it short and sweet. But in their documentation, you'll see that they apply text weights on it. So if you want to say, I want to give more favoritism to the text results versus the search results, versus the vector results, you can play with those numbers and say, actually, I'm going to give more weight to text versus more weight to the vector search. And then you can do that with applying some weights over here as well. Okay, so now we're at the point where we're going to wrap it up. This is normally when my presentations, I would turn it to the audience and ask for any questions. I'll say, and I'll keep repeating myself on this one. Please, if you're running any questions, you're not sure about this stuff, don't hesitate to ping me. We can find some time. I would gladly love to get on the talk, and it's great to give these presentations, but I get a lot of sort of enjoyment of actually being able to talk to people about this and see the passion there. So just where are we at right now on this stuff? So we're still working our way through some of these results. There's a couple challenges that we're running into. Our data sets that we're working with, because they're user-generated images, can sometimes be a bit small. And I did talk to the folks from Mongo about this, and they said that their vector search is really designed to optimize for larger data sets. So when you give it like 4 or 5 results, it doesn't tend to always give you the best search results back, which is one. So we're still working around with that. We are playing around with things like maybe the number of words. Do we start to maybe, if there's a lot of words in that search string, do we start to give more weight to the vector because maybe more of the meaning is important versus keywords? So we're playing around with that as well and just seeing how it can do that. But this is really the hardest part of this. The setting this up is actually relatively easy once you get the hang of it. It's actually, you're going to be spending most of your time in the indexing space of how do I get the results to be really good. The next thing I would be looking at is playing around with the large vectors. So you can play with the different vector size and the number of dimensions in the in the vector embedding side here. You can specify the number of embeddings that you can do. I can tell you we were originally on the ADA model, which is one of their ones from a year and a half ago. They've since launched out, say, the text embedding 3 small and the text embedding 3 large. And the results we get from search are a lot better, but they're much bigger in vector embeddings as well. But you can specify the number of dimensions. I'm just trying to make sure in here when you're creating your vector embedding, say, this is what I'm looking for. Again, this is another thing that you can look at and play around with. It's just like, how many results do I have? What's the dimensions? And see, am I getting better results with one versus the other? The other thing you can look at is you can start to play with sort of the traditional boost scores for text search. And if you look on the Mongo site, there's lots of different techniques on how you can play with boosted different text search scores to get better results, improve, and get more favoritism weights to depending if the keywords are at the beginning or not. So that's just one other thing that you can play with as well. And then lastly, this is one of the things we were doing down this path of sort of really trying to optimize this. And we stopped there a little bit because I was talking to a colleague of mine, and he gave me a different idea about what some other people are looking at is that this adds a bit of cost and it adds a bit of latency. But what we're trying to do is like, we're running a query and the aggregation to Mongo, and then we're trying to basically figure out of these, say, 20 results that are returned, which are the most relevant, and can you filter out the ones that are no longer relevant? And so how to do that is like playing with the weights and things. It's a little bit, you're really trying to get that semantic meaning. One thing that I've heard about and I'm going to start looking at is, can you do final stage? You do your vector aggregation, you do your text aggregation, you combine the results, and let's say you look for 20 before you return them back to the user. Take that and just run that up and do an additional call to OpenAI, and then just do get the LLM to do a comparison for you and just like filter some of the results out. So ask it a prompt and say, this is the original search string. Here's 20 results. Can you order them by relevancy and discard any of them that you think are not relevant? This will add a cost, obviously, and it will add a bit of latency, but you will tend to get much better search results because you're doing like a final pass through an LLM, and you're basically objecting to say, I am looking for X, please sort these 10, 20 different results based on X, and please discard anything that you think doesn't really match as well. Again, we're still in the early stages of playing with this, and I'm more than welcome to share our progress, but it is something that I've heard, and I've been talking to other people about this, is saying a lot of these tweakings with these engines is really trying to find the most natural, meaningful results, and this is what an LLM is really good at. Okay, I'm going to wrap it up there. I've already getting close to about 35 minutes. I want to first thank you again for taking the time, and hopefully you got to this part of the presentation. Again, I've shared out on my LinkedIn page. I've got all my contact information there. So if you have any questions, any concerns, you want to jump on a quick call, just chat or pick my brain, or you want to go through some code and look at this, I'm always available. Just drop me a line. I'd love to chat about this stuff. And I hope you enjoy the rest of your presentation. And I want a big thanks to all of your organizers for this. And thank you very much. Appreciate it, guys.